This conference will now be recorded.
So from today onwards, we'll try to discuss about Kubernetes. What is Kubernetes? How to set up Kubernetes clusters, and how to deploy and manage applications in Kubernetes clusters. We'll try to understand. But before I go for a Kubernetes, we already discussed about container. Basically containers, what is container, how it works, using Docker container platform. And also we discussed about container orchestration. Container orchestration, what is container orchestration and how it works, so that is Docker Swarm. Containerization and container orchestration. And also I have given an assignments how to deploy our applications that can be microservices, your microservice applications or monolithic applications also we can deploy in Docker as a containers. But most of the times we will deploy microservice applications using Docker. We will try to build that microservice as a Docker image and we will run that microservice as a container. And that can be deployed in a normal Docker or that can be deployed in a Docker Swarm also manually. But at the same time, if required, we can deploy using Jenkins also, a continuous integration tool. Whenever there is a change in the code, using Jenkins, we can continuously integrate, build that application package, build a Docker image, and deploy the Docker image into the Docker, normal Docker, or that can be a container orchestration platform like Docker Swarm also we can deploy using Jenkins. I gave assignments, but I hardly see people are working on those assignments. That is very, very important. You will struggle later. You are not realizing how important that assignments are, how important these classes are. You are not at all realizing. I cannot, force more than this. If you have done it, then good. If you don't do, you will struggle a lot after finishing this course when you are attending the interviews, when you are, joining into the companies, you will struggle understanding the, applications, how it works. I see only like few people replied saying that they are done. Not sure what is the problem with others. I gave 2 days break also, Saturday and Sunday. You guys requested, sir, I will complete the Docker and Docker Swarm practice. So make sure you have utilized and you have done that. I cannot force more than this. And let's continue with Kubernetes. What is Kubernetes? What is Kubernetes? Again, Kubernetes is again container orchestration software. It's again container orchestration software or tool, right? Container orchestration tool. So Kubernetes is a popular container orchestration software. So we will discuss about all these things. What is Kubernetes? Advantage of Kubernetes, Kubernetes architecture, how to set up the cluster, how to deploy the applications, all these things we'll discuss. So first, let's understand what is Kubernetes. Kubernetes is an orchestration engine, container orchestration engine, container orchestration engine, container orchestration software, tool, all are same. And it's an open source platform for managing containerized applications. Kubernetes is an orchestration software and open source platform, open source software for managing the containerized applications, which means for managing the containers. So as any typical container orchestration software, what is the responsibilities of Kubernetes? Using Kubernetes, or what Kubernetes does, or using Kubernetes, what we can do. Using Kubernetes, we can deploy the containers. We can deploy the containers, which means Docker images. We can deploy Docker images as a containers. We can do the container deployment and also scaling and the descaling of containers, which means increasing the replicas and decreasing the replicas of that application containers can be done. That scaling can be, as I already told in Kubernetes, we can manually scale and we can achieve auto scaling. Auto scaling of what? Auto scaling of containers. Auto scaling of containers. Kubernetes is container platform, guys. Containerization orchestration tool. It's a container orchestration tool. Does Kubernetes will manage your servers? Does Kubernetes will scale your servers? No. Kubernetes will not manage the servers. Kubernetes will not scale the servers. Within a given servers, within a given cluster, does Kubernetes can manage containers and scale the containers and orchestrate containers? Yes. But if something goes wrong with servers, your Kubernetes servers, where your Kubernetes is installed, Docker is installed, or where your containers are running, if something goes wrong with server, maximum what Kubernetes does or any other container orchestration does, it will shift the containers. I mean to say, it will recreate the containers in another machine. But is it going to recreate a new machine where again Docker Kubernetes software will be installed automatically? No. So Kubernetes is only a container orchestration software. Kubernetes responsibilities includes deploying the containers, scaling the containers, and managing the containers. And also if there are multiple containers, multiple replicas for that application, will it do the container load balancing also? If I have multiple replicas in that cluster, it does the container load balancing. So this is container orchestration responsibilities. Kubernetes, can I call Kubernetes is a replacement for Docker? Is Kubernetes is replacement for Docker? No. Docker is containerization. Kubernetes is container orchestration. Kubernetes is not a replacement for Docker, but can I consider it as a replacement for Docker Swarm? Is Kubernetes is a replacement for Docker Swarm? Yes. To manage containers, instead of Docker Swarm, we can use Kubernetes. Kubernetes is very complex than Swarm. Kubernetes is complex than Swarm, and it requires more work to deploy the applications. It requires more work to deploy the applications in Kubernetes compared to the Docker Swarm. Docker Swarm is very simple and straightforward. But when it comes to Kubernetes, it is little complex than Docker Swarm and requires more work to deploy in Kubernetes. But Kubernetes cluster is very strong. Kubernetes cluster is very strong. Kubernetes cluster, I mean to say Kubernetes has a lot of features compared to the Docker Swarm. Basically, Kubernetes has a lot of learning curve, which means Kubernetes has a lot of concepts. Kubernetes has a lot of features, which means Kubernetes has a lot of concepts. So do we need to understand all those concepts to deploy and manage the applications in Kubernetes? Yes, it has a lot of learning curve. So Kubernetes is initially developed by Google. Kubernetes is initially developed by Google, which means born in Google. So who implemented or who invented Kubernetes initially? Google. So Kubernetes is written in Go language. Kubernetes is developed in one programmatic language called Golang. So Kubernetes is initially developed in Google, written in which language? The Kubernetes software is developed in Go language. Which means, do I need to learn Go language to deploy and manage applications in Kubernetes? No, not required. Kubernetes is developed in Go language. Kubernetes is basically APIs. Kubernetes has lot of APIs, application programming interfaces, but we no need to learn Go language. Using command line tools, can I invoke those APIs to deploy the applications, delete the applications, and manage the applications using some CLI? Yes. This Docker and Docker Swarm also has APIs. Are we using some kind of a CLI, command line interface, where we are executing some commands to create, update, delete your applications in the Docker or Docker Swarm? Yes. Similarly, Kubernetes also implemented in some programmatic language called Golang. So we no need to learn Golang. We can deploy, manage applications using tools like CLI tools, command line interfaces. So born in Google, written in Go language. Most of the applications in Google, like Gmail, YouTube, all those applications are following microservice architecture in the background, and all those microservices are building and deployed as a containers, but they are not deployed as a normal way. They are deploying using container orchestration tool like Kubernetes. But later, Google has donated Kubernetes. Google has donated Kubernetes to CNCF. Google donated that software, or Google hand over that software to CNCF. What is CNCF? Cloud Native Computing Foundation. CNCF, Cloud Native Computing Foundation. So Google donated Kubernetes to CNCF, Cloud Native Computing Foundation, in 2014. In 2014, Google donated to CNCF, which means now who is owning and who is managing Kubernetes? Who is owning, who is managing Kubernetes? CNCF. So Kubernetes version 1.0, the first version of Kubernetes is released. The first version of Kubernetes was released into market for public on July 21st, 2015. In 2015, July 21st, Kubernetes version 1.0 was released to public, which means for any IT company, for any applications, they can start using Kubernetes to deploy applications and manage applications, but they released to market in 2015, which means how old Kubernetes is now in IT industry, which means from how long people are started using Kubernetes to manage their containers, approximately 7 to 8 years, 2015 for market. But before 2015 itself, Google was using for their applications. Google was using for their applications before 2015 itself. But other applications, like any other public IT companies for public applications, Kubernetes is released to market in 2015. First version. Now the current stable release, the current stable release of Kubernetes was this one, version 1.22.2. But again, that can be new also now. Now, guys, this is the official website of Kubernetes, kubernetes.io. Kubernetes.io. This is the official website where you see complete details of Kubernetes. It has very good documentation. It has very good documentation. You can understand what is Kubernetes, how to set up Kubernetes, how to use, how to deploy. Very good documentation. Everything we can get from this documentation itself, this website. Now, if you see what is the current release, stable release, if you see again 1.23.4, but major version is 1.23. Major version is 1.23. Minor in the sense within the 23, like 1.23.1, 1.23.2, like that it is there. But current stable release is 1.23. So if you see within last 7 years, how many versions that Kubernetes software itself, how many versions has been changed for Kubernetes software itself? Almost 23 major versions, which means you can understand how many features they have added to Kubernetes. Kubernetes is again one software, one application. It may has a defects also, bugs also. So within last 7 years, how many features or how many bugs they might have fixed, you can understand. So within last 7 years, 23 versions has been released to market for Kubernetes. So this is current release. When they have released to this 1.23, this release history, if you see, last month 16th, February 16th. So they have released. But again, these versions are also important. Sometimes in the interview, they'll ask what version of Kubernetes you are using in your project. Are we going to use or upgrade latest version immediately in our application or project? If you are using Kubernetes, no. In my current project, still I am using version 1.19. Version 1.19 in current project. Still we are using 1.19. So it is not like you are going to immediately upgrade, right? So based on the features which they have released and based on the features you want to use in your application in Kubernetes, you will upgrade, but not immediately, because it may have some defects also. This Kubernetes itself is one software, one application, like normal application. It may have some defects also. So it may have some defects also, so you will not immediately upgrade, right? Or you might need to upgrade some files which you are using to deploy in Kubernetes in the latest releases because of some compatibility issues. So you will not update immediately. So is everyone clear? What is the current stable release? And if in the interview if they are asking, try to say 1 or 2 versions older than the latest version. Okay. So now, so Docker which version? Again, that can be any version, but again, not latest. So now, let's try to understand what is the features of Kubernetes, what Kubernetes is offering. Like any other container orchestration software, Kubernetes have a scheduling. Automated scheduling, which means Does Kubernetes will schedule your containers on the cluster nodes the way Docker Swarm, is scheduling your containers on the cluster nodes? It's similarly same feature. Kubernetes also have an advanced scheduler to schedule containers on the cluster nodes. Kubernetes provides advanced scheduler to schedule or launch containers on the cluster nodes based on the resources available in the nodes. Automated scheduling. Again, here again it's a cluster, Kubernetes cluster, which means do have group of nodes. Kubernetes is again implemented in a cluster background, which means if I am using Kubernetes, do have group of servers? Yes. In that group of servers, Kubernetes cluster, do we have a masters and workers again? Yes. So if I want to schedule, if I want to deploy some application, if I want to deploy one image, if I want to deploy some image application in Kubernetes cluster, again, whom should we contact? Master. Does that master will have an automated scheduler? I mean to say, does master have a scheduler which will schedule the containers on the cluster nodes based on the resources available in the nodes? Yes. Yes. Kubernetes has a self-healing capabilities. Kubernetes has a self-healing capabilities. What is the meaning of self-healing? Self-healing capabilities. Recreating the nodes. It is not going to recreate the nodes as I already told. Kubernetes is not going to manage platform. It is going to manage only containers in the form of pods. So self-healing in the sense recovering from the failures or errors. So Kubernetes replace or reschedule what? Kubernetes will replace or reschedule containers if that container goes down or some node also went down. Suppose some node goes down, what will happen to the containers which is running in that node? What Kubernetes does? It will shift the containers to other node. But here Kubernetes will not manage the containers directly. I'll come to that point. In Kubernetes will not manage the containers directly. That will be managed using one more concept, one more object in Kubernetes called pod. So what is pod? How to schedule pod? We will discuss later. Kubernetes will manage the containers, but not directly. Kubernetes will manage the containers with the help of pod, Kubernetes pod. So what is pod? I will discuss later. Now in Kubernetes, will I able to deploy rollout? Will I able to roll out my application? Whenever there is a change in my application, I have created a new Docker image for that change. So will I able to roll out that application, that change without bringing the application down? Rollout. Zero downtime deployments. The way Docker Swarm also supported, does Kubernetes also supports rollouts without bringing the application down? Yes. And also, if something goes wrong with that version, that change, that application is not working as expected with new change, new image, do I have an option to roll back that application to the earlier state? I mean to say for the previous image? Yes. So we have a rollback features in Kubernetes. And scaling. Kubernetes can scale up and scale down the application. I mean to say we can scale up and scale down the containers, number of replicas as per the load using CLI, which means using manually, we can scale. Does Kubernetes supports auto scaling also? Auto scaling of containers, basically pods based on the CPU and memory usage, based on the CPU on the container, based on the CPU utilization on the container, based on the memory utilization on that container. Does Kubernetes scale that? Yes. Kubernetes supports scaling. Scaling of what again? Does Kubernetes will scale the capacity of your servers? Will it increase the servers? Will it increase the capacity of the servers? No. Using Kubernetes, we can scale pods. We can scale pods. So, again, there are two types of scaling. There are two types of scaling. What are those guys? There are two types of scaling. What are those? Vertical and horizontal. Vertical and horizontal. So, let's say this is my Kubernetes cluster. This is my Kubernetes cluster. I have a master. I have a workers. I have a masters and I have a workers. So in Kubernetes, we will not deploy containers directly. We will not deploy containers directly. Kubernetes will not manage containers directly. In Kubernetes, we can deploy what? Pod. So within the pod, what we will have? Within the pod, what we will have? Within the pod, we will have a containers. Within that pod, we will have a containers. Within the pod, we will have a containers. Okay. Now, let's say I deploy like this. While creating this pod, do I have an option to set how much CPU, how much memory, minimum it is required for that pod container, and maximum how much it will take, how much it can take? I can define in the form of resources. I can define in the form of resources like CPU. I'll come to this in detail later. What is resource requests? What is limits? I'll come to this. So limit, if I say CPU 1, memory 1 GI, this is limit. What is the meaning of request? Request also you can define CPU, something like this. Resource request and limits. So resource request is like minimum CPU and memory required for deploying this pod container. So minimum guarantee resources you will get. But whenever there is a load, how much maximum it can utilize from that machine, how much CPU, how much memory this container of this pod can utilize? 1 GB. Now, when there is a lot of load on this application, right, we can scale this vertically or horizontally. If it is a horizontal scaling, instead of one replication. So instead of one replica, can I have 2 replicas? I mean to say, can I have a 2 pods like this? Maybe in this node or other node? Yes. Horizontally, with same configurations, with same resources, one more pod. This is horizontal scaling. Does Kubernetes supports horizontal scaling? Yes. Manually also we can increase the number of replicas. Whenever there is a load on this application, based on this, it can scale automatically. Horizontally it will scale. What is the meaning of vertical scaling instead of horizontal scaling? What is the meaning of vertical scaling? vertically increasing the capacity of this pod, which means changing the requests and limits. So horizontal in the sense, horizontal only one replica, but changing the capacity, increasing these resource requests and limits. Does Kubernetes supports vertical scaling of your pods, horizontal scaling of your pods, either manually or automatically? Yes. But which one is mostly used? 99.99%. What type of scaling we will use? Vertical or horizontal? Whether it's a servers, whether it's a containers, whether it's a servers, whether it's a containers, we are going to use horizontal scaling. So is everyone clear? Kubernetes can scale up that pods containers based on the load manually or automatically. We can scale the containers. In each pod, how many containers are there? I'll come to that. I have not yet started what is pod, how to deploy the pod. Still, I am discussing the features of Kubernetes. So, guys, it's a 22 to 25 days session. No need to worry. Each and every point will be discussed, but you need to attend all the classes and practice. Then only you can become an expert in Kubernetes. If you practice all these topics, whatever I am discussing in Kubernetes, you can crack CKAD certification, Certified Kubernetes Application Developer, CKAD also you can crack the certification, and CKA also you can crack, Certified Kubernetes Administrator. That much extent we are covering the Kubernetes here and Dockers here. But only thing, lot of practice is required. Lot of hands-on, lot of practice is required. As I already told, it can do the scaling and also load balancing. What is the meaning of load balancing? If I have a multiple replicas like this for same application, I am creating a multiple replicas, multiple pods. Do I have a load balancing within the cluster? Service discovery within the cluster? Service discovery. Instead of using IPs for intercommunication, can I use some kind of a DNS name, service name within the cluster to discover these pods and load balance these pods? Do you have a load balancing and service discovery feature here also? Yes. It can load balance the pods. It can discover the pods and route the traffic. We have a service discovery and load balancing also. Within Kubernetes, with Kubernetes, you no need to worry about communication, networking and communication within the cluster. Within the cluster, Kubernetes will automatically assign IP addresses to the pods here. Automatically assign IP addresses to the pods and a DNS name. DNS name for those pods that can be used to access within the cluster. So we have a service discovery and load balancing in Kubernetes. And also storage orchestration, storage. Again, with Kubernetes also, what we are trying to manage? We are trying to manage our containers. We are trying to deploy our containers using Kubernetes. Again, if your containers are deleted and recreated, do you have a data, whatever is part of that pod container? If the container is deleted and recreated, do you have a data, whatever is part of that pod container file system? No. So we need to use values. So does Kubernetes also has a future as does Kubernetes also support values? Yes. So with Kubernetes also, you can mount a storage of your choice. You can use local storage, or you can use cloud storage like EBS, or you can use network storage like NFS. You can mount any storage with your pods containers. Okay. So it has a storage orchestration also, managing the storage for your containers. But before we set up Kubernetes cluster, before we deploy Kubernetes cluster, we need to understand the Kubernetes architecture. Kubernetes architecture is very, very important, guys, in the interview perspective also. Kubernetes architecture is very, very important. Lot of questions comes in the interview on that architecture itself. They will ask you to explain Kubernetes architecture and what is what in this architecture. So they will ask what is kubectl, what is API server, what is scheduler, what is this control manager, what is etcd. They may ask what is kubelet, what components are part of master machine, what components are part of worker machine. You may get lot of questions on Kubernetes architecture. And this is very, very important to understand how Kubernetes works. In the background, how Kubernetes works, how Kubernetes will manage your pods, how Kubernetes will schedule your pods. This is very, very important to understand how Kubernetes works in the background. As I already told, Kubernetes implemented in what background? Cluster computing background. Kubernetes implements a cluster computing background. Everything works from Kubernetes cluster. Everything works from inside a Kubernetes cluster. What is the meaning of Kubernetes cluster? What is the meaning of Kubernetes cluster? As I already told, cluster. As I already told, same concepts we already discussed. Docker Swarm cluster. Similarly here, Kubernetes cluster. What is cluster? Cluster is basically group. Cluster is basically group. Group. This cluster is used in many locations, right? So group, cluster is nothing but a group. Like in our villages also, there will be a group of people, doing, organizing as a, self-managed group, and they are going to, save some money, right? Like similarly, we call them as a cluster, one cluster. Similarly here, this cluster is nothing but a group that can be anything. Group of people, group of servers, group of something, group of databases, group of application servers, like that. Similarly, this group can be anything. This Kubernetes cluster, so it's a group of what? Someone is saying it's a group of containers. Is it correct? Before containers, it should be a group of servers. Do you need servers or nodes to deploy those containers? Before group of containers or pods, it's a group of servers. Kubernetes cluster is nothing but a group of servers, group of nodes. So group of servers or nodes. In that group, we will have again what? We will have one or more masters and rest of the nodes as workers. It's a group of servers or nodes. We will have one or more masters and rest of the workers. Now, if I want to set up Kubernetes cluster, do I need some servers like this? Do I need some servers like this? Maybe again you have a question, sir, is it mandatory to have multiple servers in the cluster? Can't I set up Kubernetes in single node? Can't I have a single node Kubernetes cluster? Can't I have single node Kubernetes cluster? Single node in the sense only one node, one server. That is a master and a worker kind of itself. So can't I have a single node Kubernetes cluster? Yes. You can have a single node Kubernetes cluster, but are we going to have single node Kubernetes cluster in your actual applications where you can deploy multiple pods, multiple applications in that cluster? No. But single node Kubernetes clusters can I use for local deployment, local development? Like as a developer within my laptop, can I set up a single node Kubernetes cluster where I can try to deploy locally and test whether it is working as expected? Yes. But for deploying for actual like a end users or QA team, are we going to have a excuse me? For like for QA, for dev environment, for QA environment, for UAT, prod, pre-prod environment, are we going to have a single node Kubernetes clusters? No. It's a multi-node Kubernetes cluster. Multi-node Kubernetes cluster, which means multiple servers like this. So I will have some servers. This is one server. One server. One virtual machine. This is one server. This is one server. This is one server. Now, as I already told, few machines will act as a masters, few machines will act as a workers. What is the role of master? What is the role of master? We will have some master, we will have some workers. What is the role of master? So master is orchestrating. Master is orchestrating. Master is managing that cluster. So the role of the master here, basically, the master node is responsible for managing that cluster. Managing the cluster, which means master is responsible for scheduling. Master is responsible for scheduling your pods into the cluster. And if something goes wrong with your pods, again, who is responsible for rescheduling those pods? Which means containers again. Who is going to schedule and who is going to reschedule if something goes wrong? Master. And if something goes wrong with one of the worker, if something goes wrong with one of the worker itself, again, who is responsible for creating the pods into another node, whatever it was running in that failed node, again, who is going to do that? Master only. So master is responsible for managing that cluster. It will handle the orchestration, that management, right? So that is the role of master. So what do we do with workers? What is the role of worker? Typical any worker, like your manager. What is the role of your manager? Manager in your office, you have a manager, right? He will manage the team. He will assign the tasks. He will track the task, whether that guy is doing the task or not, whether he is completed the task or not. If he is not doing well, his manager is going to reassign the task to another developer or any other guy. Similarly, this is what Kubernetes master also does. Kubernetes master will schedule the pods to the workers and it will make sure those pods are running. If something goes wrong with those pods, it will try to reschedule those pods again in the same node. Or if the node itself is not proper, if the node itself is down, what master will do? Does master will try to reschedule those pods to other nodes, other workers? Yes. That is what master role. And what is the role of worker? Basically, worker nodes are the nodes. Worker nodes are the nodes where actually application is running. Worker nodes are the nodes where the application is actually running. Application in the sense here, in Kubernetes, we are going to deploy that as what? Pod. So worker nodes are the nodes where actually your application pods, your application containers are running in the cluster, right? So we have a master node, we have a worker node. So what are the components of master? This master, we will call it as control plane also, guys. Control plane, or we call it as a master. So what are the part of control plane? What is the meaning of control plane? The name itself, it is saying control plane. So the master is also called as control plane. The name itself, it is saying control. Is it going to control something in this cluster? It is going to schedule your pods. It is going to manage your pods. It is going to reschedule your pods, like that. Now, as I already told, if something goes wrong with this server itself is down, is it going to recreate another server? I mean to say, is it going to recreate one more machine? Does Kubernetes does that? No. Kubernetes, as I already told, it is not going to manage, it is not going to control your server. It is going to control only the parts which is running in that server. It is going to control only the parts which is going to run in that server. If something goes wrong with this server itself, what maximum it will do, as I already told? What maximum it will do, as I already told, if something goes wrong with this container, I already have some parts in this. I already have some parts in this server. Maximum what it does? It will try to reschedule. It will try to reschedule these parts in other node, wherever node is healthy. But am I going to get another virtual machine? I mean to say, am I going to get another VM automatically in the cluster? Does new VM will be created and that will be joined to this cluster automatically by Kubernetes? No. That is not part of Kubernetes, right? But if I am using some other cloud platforms like AWS, Azure, GCP, if I'm going with managed Kubernetes clusters, if something goes wrong with your Kubernetes workers, does that respective cloud provider like AWS or Azure or GCP, is it going to recreate your worker node and schedule, join that node again to the cluster? If you are going with managed Kubernetes clusters like AKS, like EKS, like GKE, does that provider manages the machines? Yes, but not Kubernetes. Don't get confused. Is everyone clear? What is the role of control plane or master in Kubernetes? It is only going to control pods in the nodes. So, as I already told, Kubernetes will not manage the containers directly. It is going to manage containers with the help of pod. I will explain what is pod. Just understand the architecture first. So without understanding this architecture, it is very difficult how it is working in the background. Now, in the control plane, what are the components we will have? In the control plane, what are the components we need to have? First of all, in this diagram, it is not shown. Do I need to have container runtime in each and every server, whether it's a master or worker? Do I need to have a container runtime? Container runtime in each and every server, whether it's a master or worker. What is the meaning of container runtime? What is the meaning of container runtime? this container runtime software, container runtime software, like a Docker or container D, Rocket, or we have a core OS or CRIO, like this. These are container runtimes. We need a container runtime because Kubernetes is going to create a pods. Within the pods, you have a containers. Do we need a container runtime to run those containers in the Kubernetes nodes? We need container runtime. That can be Docker, that can be containerd like that. Guys, can I use like a containerd also as a container runtime in Kubernetes? Can I use Docker also as a container runtime in Kubernetes or CRIO, like any other containerization softwares in Kubernetes? Or it is mandatory to use Docker as a container runtime? It is not mandatory to use Docker as a container runtime. You can use containerd also as a container runtime or CRIO also as a container runtime like that. But when it is a Docker Swarm cluster, will it able to manage containers using any other containerization software except Docker if it is a Docker Swarm? If it is a Docker Swarm cluster, only Docker containers. But when it comes to Kubernetes, this container runtime, can I have Docker as container runtime? Or can I have containerd also as a container runtime? Yes. In fact, let me tell you one news. Kubernetes deprecated Docker. How many guys heard about that news? Kubernetes deprecated Docker. Did you guys aware that Kubernetes deprecated Docker? What does it mean? What is the meaning of Kubernetes deprecating Docker? Kubernetes is not officially going to support. Kubernetes is not officially going to support. Kubernetes is not officially going to support Docker as a container runtime software. Kubernetes is not officially going to support a Docker as a container runtime. Sir, what is this? You wasted my time like 18 days. You discussed about Docker. Now you are saying Kubernetes is not Kubernetes is not supporting Docker. You discussed Docker 18 days, almost 30 hours, close to 30 hours you discussed, and you are saying now Docker is not supported in Kubernetes. Does it mean it's end of Docker? There is no life for Docker in software now? No. Docker is still powerful container software. Docker is still powerful container software. Even though Docker is deprecated in Kubernetes, can I still use Docker? Yes. For what purpose? Can I still use Docker for creating images? Not creating a containers, Dinesh, not creating a containers, creating images. Can I still use Docker to create my images, Docker, that container images? Can I still use Docker file to build my images? Can I still use Docker commands to build my container images? Yes. But if I am using Docker to create images, is it possible for me to deploy those images in Kubernetes? If I am using containerd or if I am using CRIO, because Docker is not officially supported now in Kubernetes, can I still use those images, whatever is created using Docker? Can I deploy those images in my Kubernetes cluster even though I am using containerd or some other software as a container runtime? Yes. Yes. We can still use Docker to build the images. We can still use Docker files. We will write a Docker files. Using Docker file, you can create that image. This is your source code. This is your source code. Can I still have a Docker file in my source code like this, even though I am using Kubernetes? In Kubernetes, I am not using Docker. Can I still use Docker file to create images? Yes. So in your build server, like Jenkins server, can I still use this command to build my images? Can I still use this command in my build server? This is your CI/CD server, let's say. So I can still build my image in my registries. In my registries like ECR or Nexus or JFrog or Docker Hub, whatever it is. Can I push those images, whatever images I created using Docker? Can I push those images to the registries where I can maintain centrally those images? Yes. Yes. I can have those images here. Whatever images I have created using Docker, can I deploy those images in my Kubernetes cluster, even though my Kubernetes cluster is created with the containerd runtime instead of Docker runtime? Yes. You are not having a Docker here, but this image, whatever image you created using Docker, is it possible to run this image as a container using this containerd runtime or CRIO runtime or any other runtime? Yes. That is because there are standards. There are standards. Every container runtime is following those standards. OCI. What is the meaning of OCI? Open Container Initiative. Open Container Initiative. Guys, try to focus on your what I am teaching. All your questions will be answered. Will the same commands creating in containers in containerd, will it work? Because I am going to deploy whatever images I am going to create. I already created, right? I am going to deploy. So focus on what I am discussing. In the interview also they will ask what is OCI, OCI. Don't, go forward. All these things will be discussed. How to deploy applications in Kubernetes. What commands we are going to use. We will discuss all those things, but focus on what I am trying to say here. So there is a concept called OCI, Open Container Initiative. It's a standards. It's basically standards defined around container images. Basically container images or formats. So now every containerization runtime like Docker, containerd, all these are following these standards defined by OCI. Like Docker, containerd, CRIO. All these containerizations are following the standards defined by OCI. Which means even though I am using Docker, if Docker is following these standards, Open Container Initiative standards for container images or formats, whatever images is created using Docker, can I run that image in containerd? Because containerd also following the Open Container Initiative standards. If you are from a development background, you can understand there is an interface. If you are from a development background, you can understand there is a interface, there is a implementation. Interface is like a standard. Implementation can be done in many ways. If this one is also implementing same standard and this one also implementing in same standard, whatever is created using this Docker, that image, can I run that image as a containerd in the containerd runtime? Yes. Docker is still powerful software. Docker is still powerful software because Docker has very good what? As I told in the beginning itself, Docker has very good. Docker is having strong CLI or API around container images, right? So it has a very good CLI and API to create images and all those things. So we can still use Docker. It's not end of Docker. We are still using Docker. Even though Kubernetes deprecated Docker, we will still use Docker. We are still using Docker to create images. But once this is done, your image is created and maintained in the registries. When it comes to deployment, can I have containerd runtime in my Kubernetes cluster? Can I request my master to deploy that image? Can I request my Kubernetes master to deploy that image even though I have a containerd runtime here? Yes. So Docker deprecated Kubernetes. This is Docker basically, or Kubernetes deprecated Docker. You can see here. They itself saying what? Don't panic, which means don't get tensed or don't be panic. So there itself is saying, you no need to panic. It's not as dramatic as it sounds. You no need to panic about this news. They are itself saying, you don't need to panic. It's not as dramatic as it sounds. So why they are deprecating Docker? Because there are a lot of reasons. I have explained one in detail in one video in our YouTube channel. In our YouTube channel, Mithun Technologies DevOps YouTube channel, right? There is a detailed video on that one. Kubernetes deprecating Docker. So why it is deprecating? What is the problem with Docker in Kubernetes? To make it simple, guys, Docker is not actually a container runtime. Docker is not actually a container runtime. So Docker is still using internally containerd as a runtime. So it is like this actually. You have a Docker, but high level you see that is only one package. But Docker is internally having multiple things. Docker is basically internally using again containerd only. Docker is internally again it is using containerd only. On top of this containerd, they have a lot of things. They have built a lot of things like CLIs, APIs to interact. So we have a Docker shim. So basically it has a lot of things like this internally. Something like this. So internally Docker is still using containerd as a runtime. but they have a lot of additional layers to manage those containers with the help of CLIs and APIs. Now Kubernetes can directly work with containerd. Kubernetes can directly work with containerd. Then why additionally they need to support these additional layers? If there are some compatibility issues when they are using Docker, they need to fix those issues in these layers. So if the Kubernetes can directly work with containerd, why they need to additionally support the Docker? So for that overhead, Kubernetes has deprecated Docker. Now Docker is not officially supported as a container runtime in Kubernetes. It is not officially supported. But if you want to still use, will you be able to use? If you want to still use, will you be able to use? Even though it is not officially supported, yes. But if any issues comes in the container, I mean to say, if any issues are coming, if you are using Docker as a container runtime, does Kubernetes will fix those compatibility issues in future releases? No. So Kubernetes deprecated Docker. In future, they might stop supporting Docker produced images. That is nothing to do with the Docker. That is OCI standards. So all these container softwares are using OCI, Open Container Initiative. It's a standards around container images. So if you have created using Docker, that can be deployed in containerd CRO also. Similarly, even though you created using this software, will I able to run that image if I am using Docker also? Forget about Kubernetes. Forget about Kubernetes. Kubernetes is later. If whatever image I created using Docker, can I directly deploy that image in containerd? Or whatever images I have used, created using containerd, can I deploy in Docker also? Yes. That is different. This Kubernetes is different. Don't get confused. Okay. So I strongly recommend you to go through this video, Kubernetes deprecating Docker. In our YouTube channel, it is there. So why it is deprecating? Does it mean it's end of Docker? Does it mean it's end of Docker? Or still Docker is a powerful tool in DevOps? How we can use, you can understand in detail. I strongly recommend you to go through this video. Before coming to tomorrow's class, I want you to go through this video. Now, let's continue. Since Docker is deprecated, can I use containerd as a container runtime while setting up the Kubernetes cluster? Can I use containerd instead of Docker while setting up the cluster? Yes. So do I need to have that container runtime? That can be Docker also or any other, as I already told, do I need to have that in each node, whether it's a master or worker? Yes. Now, this is required. Now, in the master, we have some components, very important components now. What are the components in the control plane? API server, control manager. Like this, we have scheduler. So we have a API server, we have a scheduler, we have a control manager. And also what is the one more important component here? We have a etcd in the master. This is master. These are the important components in the master or master components. We call it as a control plane components. Now, what is API server in the master? What is scheduler in the master? What is the control manager? What is the etcd? What exactly it does? The name itself, it is saying API server. As I already told, is Kubernetes is implemented as APIs. If I want to deploy any application, deploy, update, delete any application in the cluster, do I need to invoke some APIs? Do I need to invoke some APIs? As I already told, Kubernetes is implemented in which programmatic language? Go or Go language. So do we have APIs? The moment I install Kubernetes, do I have a lot of APIs to be interacted? Yes. So to deploy any application in the Kubernetes, do I need to interact with APIs? Do I need to interact with APIs? Yes. But do you need to directly write any code to interact with APIs? Not required. So how can I deploy to Kubernetes cluster? Can I deploy using CLI? I mean to say, can I interact with that API server to deploy, update, delete? Can I use CLI? Can I use GUI also if required? Kubernetes supports GUI also, but we are not going to use GUI. Can I use CLI or GUI? So this CLI or GUI, with whom we can interact, or these guys will interact with whom to create, update, delete any application in the cluster? It has to interact with which one? In the master. Again, in the master, what is the important component? That API server. That API server. So that API server is like a front end. That API server is like a front end or entry point for our Kubernetes cluster. Kind of a front end or entry point for that Kubernetes. So if I want to do anything in my Kubernetes, whether I want to delete my application, deploy my application, whether I want to update my application, or if I want to add any new nodes to this cluster, if I want to create any volumes in this cluster, for any task which you want to perform in the cluster, whom should we interact, guys? In the control plane? This API server. So how can we interact with API server? As I already told, I can use CLI. You don't need to write a code, CLI. What is the meaning of CLI? Command line interface. So what is Kubernetes CLI? What is Kubernetes CLI? That is basically kubectl, 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 or we call it as a kubectl. This is the Kubernetes CLI. So when I am using Kubernetes to deploy this application in my cluster, am I going to use commands like this? Docker run, or am I going to use commands like this? Docker service create or Docker stack deploy? Am I going to use like this if I'm using Kubernetes to deploy my applications? Even though you are using Docker here, even though you are using Docker as a container runtime, are you going to use commands like this to deploy in Kubernetes? Even though you are using Docker as a container runtime, are you going to use commands like this to deploy? No. So everything is what? Everything is a kubectl command, kubectl. So what is the Kubernetes CLI? In the interviews they ask, what is Kubernetes CLI? What is the answer for that? Kubectl is the CLI. So even though I am executing some commands like this, kubectl commands, in the background, is it going to invoke those APIs? Suppose I am executing like this, kubectl create some options. Some options I am using. Is this kubectl is going to make a API call in the background to the API server? Does this API server will process that request in the background? Does that API server will process that request in the background? Yes. So same thing using GUI also, we can do that. But GUI we will not use to deploy. Okay. Only CLI, command line interface. So if you see in the architecture, we have a CLI. So CLI interacts with what? Master. And again in the master, what is the important component? It will interact API server. So what is that API server in the master? Very, very important. In the interview also, lot of 10 to 15 minutes, they may ask questions on this architecture. So what is API server, or what are the components of master or control plane, like that. So what is API server? That API server will interact with API. It will execute some code. It will interact with API. It's like a front end of Kubernetes control plane. It's a communication center for developers, DevOps guys, or any other people for doing any task. I want to create pod, I want to delete pod, I want to add some new node to the cluster, or I want to create volumes. Any task which you want to perform in the cluster, we should interact with whom? In the master again, it will be internally API server. API server. Now, what is scheduler? Now I am trying to deploy some application like this. I am trying to deploy some application like this. Now let me show you. So I am trying to execute this command, let's say, just to understand, make you understand. I have a kubectl. I executed a command like this in my kubectl. Now what I am trying to say, deploy this image in the cluster. Kubectl command I am executing. I am asking to deploy this image. So since there is no registry details here, from which registry it will pull this image? From which registry it will pull this image? Someone is saying daemon. It's not a daemon, Docker Hub. Docker Hub. So public registry. Okay. So I am asking to deploy this image. So what will happen in the background? First, request goes to what? Request goes to API server. API server. Whether you are doing from GUI, whether you are doing from CLI, first request goes to this API server. So what this API server does? What this API server does? That API server, it will do lot of things first. This API server, first what it does? It will validate. It will validate the request. As part of validation, what it does? It will do authentication. It will do authentication. What is the meaning of authentication? The guy, whoever is requesting, whether he is a valid user or not, it will do the authentication and also authorization. What is the meaning of authorization? Whether this guy, the guy who is requesting like this, whether that guy has a permissions to do that task, whether that guy has permissions to create the pods or not. If this guy doesn't have a permissions to create a pods, does API server will proceed further and process that request? The guy who is requesting, that guy doesn't have a permissions, authorization, doesn't have a permissions to create a pod. Let's say, does this API server will proceed further? No. So it will validate. Validate in the sense, it will perform authentication and authorization, and also whether that request is correct or not. If this guy is using This guy is using some wrong options. Again, will it throw error? Does this API server will throw error if this guy is using some wrong options? Wrong options in the command? Yes. It will validate the request. It will authenticate, authorize, and validate the data or options. If everything is perfect, then it will persist the details in etcd. If everything is perfect, then it will persist the details in etcd. What is that etcd now? What is that etcd now? So sometimes in the interview they'll ask, what is etcd? So etcd is a data store. It's kind of a database. Database for what? Is it a database for our applications? Is that etcd is a kind of a database for our application? No. etcd is a database for Kubernetes. So Kubernetes will store all these informations like how many pods are scheduled, how many nodes are there in this cluster, how many volumes are there. All this data, the cluster data, the state of the cluster will be stored in etcd. It's not a repository. It's a kind of a database, a data store. It's kind of a database, data store. So etcd is a simple key value store. etcd is a simple key value store. Kubernetes will use etcd as its a database to store some of the data like pods information, state of the cluster, like how many nodes are there, all those information will be maintained in etcd. It's a database for Kubernetes, not for your applications. So it's a data store where Kubernetes will store information about the cluster, how many pods, how many nodes, all these things. So once this is done by API server, then who kicks in? I am requesting to deploy this one. API server validated the request. If everything is perfect, it will persist the details in etcd. Then this guy comes into picture, scheduler. What is the role of scheduler? What is the role of scheduler? The name itself is saying scheduler. The name itself, it is saying scheduler. It is going to schedule the pods. It is going to schedule unscheduled pods. The scheduler will comes into picture. The scheduler will try to check, do we have any unscheduled pods? The scheduler comes here. Scheduler will assign nodes to unscheduled pods. Suppose we have some pods which are not scheduled. So the scheduler can find in etcd whether the pod is scheduled or not. Does that scheduler can find in etcd whether that is scheduled or not in the cluster? Yes. So scheduler will try to see etcd and it will try to assign a nodes. It will decide in which node that pod can fit in. But do we need someone in the nodes also to see whether that node is reachable, whether that node has enough CPU and memory? For scheduler to decide, do we need someone in the nodes also? Someone in the nodes also to see whether the node is healthy or not, whether that node has enough CPU or not. So the scheduler will assign the nodes to unscheduled pods with the help of kubelet. So we have a kubelet here. Does kubelet? We have a kubelet here. Kubelet. Guys, kubectl is different, kubelet is different. Don't get confused. So we have a kubelet and one more thing called kube proxy. There are two things here. One is kubelet, one more is kube proxy here. So we have a kubelet. The scheduler will assign the nodes to unscheduled pods with the help of kubelet. So who will decide in which node that pod can be scheduled? Who will decide which node that pod can be scheduled? That will be decided by scheduler. So scheduler will interact with someone in the nodes. Scheduler will watch the pods and it will assign the pods to specific hosts. Hosts are nothing but nodes. Now we have a kubelet. So what is that kubelet? The scheduler will interact with kubelet. Kubelet is basically an agent. Kubelet is a primary node agent software. Kubelet is a primary node agent for Kubernetes. So does the Kubernetes will use this kubelet? Does Kubernetes will interact with this kubelet running on each node to orchestrate or to manage the pods, schedule the pods, manage the pods, check the health of the pods? Does kubelet is responsible for that? Is Kubernetes is going to interact with kubelet which is running in the node to schedule the pods also, to manage the pods also? Is kubelet will be used internally by that master machine, that control plane, to schedule the pods, manage the pods? Yes. Kubelet is a primary node agent that will be running on each and every node. So this scheduler will interact with kubelet and it will assign the node. It will just decide in which node it will be running. Then again, does this API server will interact with kubelet saying that scheduler decided you are the correct node for this pod. So does API server again will interact with kubelet to create that pod? Yes. So again, once the scheduler is decided this is the right node for that pod will come here. So it will instruct to create a pod. Now what this kubelet does internally, the moment the pod is created here, the kubelet will internally work with this container runtime. That kubelet will internally work with this container runtime. Will it fire some commands internally to pull the image and create a container in that pod? Does kubelet will interact with container runtime to fire a commands to pull the image and create a container for that pod in that system? Yes. So is kubelet is responsible in the node, in the worker node? Is API server, is your scheduler, is your control managers are going to interact with kubelet to schedule, manage the pods in that node? Yes. So this kubelet is a node agent. But what is kubectl, guys? What is kubectl and what is kubelet? Don't get confused. Kubectl is what? Kubectl is what? CLI, command line interface. Kubelet is what? Kubelet is a node agent. It's a agent software. But in fact that agent is running in the master also. But in the architecture it is not shown because this is not very important in the master perspective. Do we have this kubelet and kube proxy in the master also? Yes. We have kubelet and kube proxy in the master also. But in the architecture perspective, these two are not important in the master. But even though in the diagram it is not shown that kubelet and kube proxy, we will still have kubelet and kube proxy also in the master as well. But it is not shown in the diagram. Now, The scheduler will decide. Then scheduler will interact with kubelet and it will assign a pod to that node. The kubectl will fire container commands to pull the image and create a container. Now we have a control manager. We have a control managers. What is this control managers? What control managers does? We have lot of control managers also. We have control managers. The name itself it is saying control managers. We have a node control manager. We have endpoint control manager. We have replication control manager. We have replica set control manager. Like this, we have a lot of control managers. Replica set control manager, deployment control manager. Like this, we have a lot of stuff. The name itself, it is saying control managers. So I deployed as a replication controller saying that I need one replica. Does this replication control manager will consistently watch whether that replica, whatever number of replicas I have mentioned, whether those many replicas are there or not? If something goes wrong with that replica, does this replication control manager will again replicate that pod, that number of replicas, whatever I have requested? It is going to control those replicas. Similarly, we have a node control manager. Node control manager. What is the role of this node control manager? What node control manager does? Here I have given, like we have a node control manager, we have a replication controllers, replica set controllers like this. The node controller, what it does? It is responsible for noticing and responding when any node goes down. We have a lot of control managers like replication control manager, node control manager. So the role of node control manager, for some reason this node went down. For some reason this node went down. Who is responsible for noticing and taking some action if any node goes down? That node control manager. It is going to take some action. What action it will take, as I already told? Is it going to reschedule those pods to other nodes? Yes. So these are the role of control managers. So is everyone clear, guys? What is Kubernetes architecture? In the master, what are the components we have? What API server does? What scheduler does? What control manager does? What etcd does? And what is kubelet? Is everyone clear? Very, very important. Sometimes in the interview, they are going to ask this one also. I am executing some command like this. What is happening in the background? I am executing some command like this. What is going to happen in the background? Suppose when I am executing some command like this, what is going to happen in the background? First, what happens? When you are deploying your application in the Kubernetes, what is happening in the background? They will ask. When you are creating pod, when you are deploying your application in Kubernetes, how the request will process. So first what will happen, guys? First request goes to API server. What that API server does? That API server validate the request, authentication and authorization, and also it will validate whether request comes with correct data or not. If everything is proper, then API server will do what? API server will save that information in etcd. It will store that information in etcd. Then scheduler will try to assign a node. Scheduler will try to assign a node to the unscheduled pods with the help of kubelet. So kubelet is agent for all these things. Is a kubelet is agent for master? That can be API server. Does API server also can interact with kubelet? Scheduler also can interact with kubelet. Control managers also will interact with kubelet. So it will interact with kubelet to decide which node it is good to deploy. And again, is this control managers also will interact with kubelet and see whether that node is working, whether that pod is running. If the pod is not running, again will it recreate in the same node if the node is good. If the node itself is down, does node control manager will try to reschedule the pods to other nodes? The node control manager. Yes. So all these things. So this kubelet, can I call this kubelet as a node agent, primary node agent? Yes. So since we are not, even though we are not using any container commands like Docker commands or containerd commands, internally, who is going to interact with this container runtime to fire a commands to pull the image? The kubelet. The kubelet will interact with this container runtime and fire a commands to pull the images and create a containers in the pods. Containers in the pods. Is everyone clear what is kubelet? First of all, what is master? What is worker? What is the role of master? What is the role of worker? In master, what are the components? In worker, what are the components? And what is the only component which is left in the architecture now? Needs to be discussed. Kube proxy. So what is this kube proxy? What is the role of this kube proxy? The name itself, it is saying networking proxy. It's a networking proxy. So if I want to access the applications which is deployed in the cluster internally or externally, that will happen via whom? I deployed that application in my cluster. I want to access that application within the cluster. I want to access that application within the cluster or outside the cluster. Within the cluster or outside the cluster, that will happen via kube proxy. So that kube proxy is basically networking proxy. Kube proxy enables service abstraction by maintaining network rules on the host, and it will do the connection forwarding. So kube proxy will maintain the network rules on the nodes. These network rules allow network communication to your pods inside the cluster or from outside the cluster. Whatever networking rules are maintained by kube proxy, it will allow to access our pods within the cluster or outside the cluster. It's a networking proxy. Is everyone clear? What is kube proxy? What is kubelet? What is container runtime? What is API server scheduler, etcd, kubectl? Very, very important, guys, in the architecture perspective. I can directly set up the cluster without explaining all these things, but it is very, very important to understand how Kubernetes works. In the interview also, 10-15 minutes, you will get a questions on this architecture. If they are only expecting very strong resource in Kubernetes, if they are expecting any strong resource in Kubernetes for their project, they will ask in and out of this architecture. That's why I'm trying to cover. So this is just an introduction. So tomorrow we'll try to set up the cluster. Then we will understand what is pod, how to deploy pod, all these things will continue tomorrow. But before coming to tomorrow's class, I recommend you to go through today's session and also one more important video. I requested, what is that another video? You know, video from YouTube channel, why Kubernetes deprecated Docker. Why it's deprecated? Does it mean it's end of Docker or still we can use Docker? You can understand from there. Thank you guys. That's it for today. I'll continue tomorrow. And again, I am repeating, Kubernetes is very, very important. I want everyone to attend the Kubernetes without missing. But I see attendance is very less. I cannot force more than this. If they are not attending, definitely they are not going to get a job. Simple. There is nothing here because Kubernetes is very important and you guys are not attending Docker, Kubernetes, all these things. Without knowing all these concepts, without doing the assignments and practice, you cannot crack the interview. Even though you crack by by-hearting interview questions, you cannot survive on your own. Simple. Thank you. I'll continue tomorrow.